Standard form, or scientific form as it's sometimes called, is a way of writing very, very big numbers or very, very small numbers quicker or more concisely. If you need some extra help, you can go to Corbett Maths and there are videos and worksheets. They're numbers 300 to 303. The most important thing about writing numbers in standard form is that they must appear in the format of a times 10 to the power of n, where a is a whole number between 1 and 10, so that it can't be a decimal number less than 1 and it can't be 10 or more. And the power of n, or the power of 10, is n, where n is a whole number, so that could be a number that's either negative or positive. Generally, if we're trying to write very big numbers, it's like 15,600 or 786,000, n will be positive. But if we're writing decimals, like 0.0000553, or this one, part D, it's going to be a negative value. So it will be negative for small numbers. So if we look to these examples and try and express these, the key thing is we need to write it as a number between 1 and 10. So we need to write 15,600 as a number between 1 and 10, and then multiplied by a power of 10. So the number between 1 and 10 we're going to pick here is 1.56. We could put 1.5600, but the zeros there don't add any significance, so we don't need to. Then we need to think about how many times the decimal point has moved. In the number 15,600, the decimal point is after the last zero, so it would be in here. And to get it to between the 1 and the 5, we've moved it once, twice, 3 times, 4 times. So it's been moved 4 times, so that means it's going to be 10 to the power of 4. Because it's 10 to the power of 4, what that really means is 10,000. And if we multiply 1.56 by 10,000, we'll get back to 15,000. For 786,221, the number between 1 and 10 will be 7.86221. And we'll multiply it by a power of 10. To determine how many times we do that, it will be the number of times the decimal point has moved. The decimal point is after the 1, and it's been moved once, twice, 3, 4, 5 times. So the power of 10 is 5. Example C is 0.000553. Our number between 1 and 10 is 5.53. And we'll multiply it by a power of 10. To know what the power is going to be, we need to count the number of times the decimal point has been moved. It's clearly between the first and the second zero, and we can see that it's been moved once, twice, 3, 4 times. So it's times 10 to the power of, well, it's not 4 this time, like it was previously, but because it's a small number, it's minus 4. And the reason for that comes back to our rules of indices. We should know that 10 to the power of minus 4 is 1 over 10 to the power of 4, which is 1 over 10,000. And if we multiply 5.53 by 1 over 10,000, that's the same as doing 5.53 divided by 10,000, which will get us back to our number. Example D, the number between 1 and 10 is going to be 1.20134, and we'll multiply it by a power of 10. To know what that is, we count the number of decimal places, and we can see that it's been moved once, twice, 3, 4, 5, 6, 7, 8, 9, 10 times. So it's to the power of minus 10. A minus because it's a negative number. A decimal number. One other trick, or something that we can notice, is that the power here was, the number part was 4, and if we count the total number of zeros before the 5, we can see that there are 4 of them. The total number of zeros in example D, if we count them, we can see there again that there are 10 of them, and that was the power. So that's something that we can do in terms of the smaller numbers, that's a wee bit quicker. to write from standard form to a decimal number. Now, decimal number just means that it's in terms of a base 10. This time, like binary, they could have decimal points in them. Some will, some may not. But a decimal number really is any number that can be expressed as a traditional number, as we would know it. So what we have here in the first example is we've got 5 times 10 to the power of 6. Now this 10 to the power of 6, we could think of that as being 10 times 10 times 10 6 times, and that would work out to be 1,000,000. So that's 5 times 1,000,000, which, easy enough, is 5,000,000. So that's 5 times 10 to the power of 6 would be 5,000,000. The next one, 5.231 times 10 to the power of 3. Well, 10 cubed is 1,000. 10 times 10 times 10. And we're multiplying that by 5.321. And then 5 times 1,000 is going to be 5,000. So we've got 5,321. We can always do checks with this. So the decimal point was between the 5 and the 3, and we've moved it once, twice, 3 times. And similarly, before the decimal point was after the 5, if it was anywhere after the 5, and that's been moved once, twice, 3, 4, 5, 6 times to there. And those match up with the powers above, the 3 and the 6. Example C and D, what we can see is that they're both negative, and that means they're going to be decimal numbers. And using our trick that we looked at earlier, that the number at the power is going to be the total number of zeros before the first digit. That's going to give us 0.01356. So what we had was 2 as a power, and we've got 2 zeros. In example D, we've got a power of 5, or minus 5, so that means there's going to be 5 zeros in total. 0.1, so we've got 1, 2, 3, 4, 5 zeros, and then 9356. As a check, we can see how many times the decimal point has been moved. We can see it's been moved once, twice, 3, 4, 5 times, and in the previous example, 1, 2, which is the same as the powers above.